All right, this is the Algebra 2 Pro Unit 3 Lesson 9 video over inverses of matrices. So the inverse of a matrix is the matrix that when you multiply a matrix times its inverse, it results in what we call the identity matrix, which we discussed in a previous lesson, but is this matrix 1, 0, 0, 1 for a 2 by 2 matrix. And then 3 by 3 has another value as well. But we're focusing on inverses of 2 by 2 matrices. So a lot of this is just incorporating stuff from previous lessons and then using it kind of in unison or in conjunction with each other, kind of in concert, doing different things that we've already learned and then applying it into this situation. So a couple things we need to talk about first of all. First few questions just say, use the determinant to find if a matrix has an inverse. Okay, I'll remind us briefly of something we talked about in a previous lesson. But remember, there's this idea that if a matrix has a determinant that is a value of 0, then it does not have an inverse. So again, if a matrix has a determinant of 0, then it does not have an inverse. So I'll write that down here. If the determinant of a matrix equals 0. Sorry, my X is messed up there. The matrix does not have an inverse. I'll put that in the notes for you. That's kind of one of the key concepts here. So basically, you need to calculate the determinant of the matrix in 3, 4, and 5. You can go back to that lesson 7, to find out how to do that. Once you find out it's 0 or not, that determines yes or no. So if you get an answer of 0, then the answer is no. If you get any other number, the answer is yes. That's it for 3, 4, and 5. Number 6 is one method of finding the inverse of a matrix. You are going to perform row operations. So I want you to kind of understand, you've got a row operation here that says to take row 2 and add it to -4 times row 1. So you're going to multiply -4 times row 1. That's this row right here. You're going to add it. You're going to add the answer you get. Sorry about that. Let me get that looking a little better. -4 times that, and you're going to add it to row 2, and then you're going to put the answer in row 2. So then you're going to need to write this down. Do that. Then it says to take row 2, multiply it times 1 over 14, and then put it back in row 2. So you do that. So you're going to have to do multiple steps. So you need to follow the row operations here, step by step. Once you do that, you'll get down to the final result after you do the last row operation here. Row 1 plus 3 times row 2 and put it in row 1. Once you do, you'll have the inverse. So it'll be one of the answers you see below. So a lot of steps, but not steps you don't know about. It's just things we learned from previous lessons. I think this is from lesson 5, elementary row operations. So go back and check out the video for lesson 5. I'll write that down here, lesson 5. All right, scrolling down. Use the formula for finding the inverse of a 2 by 2 square matrix. This is another method. Just to explain what this means, you need to find the determinant. You already know how to do that. So find the determinant of the matrix, and then you do 1 divided by the determinant, and then you see here how it tells us to do all these different things. So the first thing we need to do is make this new matrix where we do row, it says R2, 2. So that means to take row 2, column 2, which is the number 2, then to do negative row 1, column 2. So looking up in my matrix, row 1, column 2 would be -3. I need to do a negative of that. That's going to be +3. Then it says to do negative row 2, column 1. So I do negative row 2, column 1. That's 4. So -4. And then row 1, column 1. That's the number 1. So that's this part. Then I need to multiply 1 over the determinant of matrix M. So you find the determinant using the method we learned, then multiply this entire matrix, which means that's going to be multiplied by every single term here. So that number, whatever this number is going to be multiplied times all of those numbers. And then that will give you the resulting matrix. Number 8, determine if matrices are inverses of each other. Quite simply, if you multiply two matrices that are inverses, you will get the following matrix as your answer, 1, 0, 0, 1. So you need to go back and look at multiplying matrices, multiply matrix A times matrix B, and question is, do you get this matrix when you do that? So again, nothing new, just incorporating it into a new kind of situation. Then we have some review questions, and then I will be posting the review for our unit test on Monday. So today for me is December 9th, so we're getting close to the end of the semester. So please try to knock this out so you can be testing next week.